Hello and welcome to another session in mathematics. In this session we'll be looking at probability, but before that let us take a review of our previous lesson. Welcome back. Our focus in today's study will be on mutually exclusive events of probability. Mutually exclusive events. So let us start. We call them mutually exclusive events or addition law of probability, and we say that two events are said to be mutually exclusive when both of them cannot happen at the same time. Okay, when two events cannot happen at the same time, then we say that these events are mutually exclusive. Take for instance, let's say a man who wants to wed, then on the day of his wedding, let's say trying to bury his father too, burial of his father. So you see that these two things cannot happen at the same time, because number one, he should be in the church trying to wed, and he cannot be also in the church trying to bless the corpse of the deceased. So at this point we say that these two events cannot happen at the same time. When two events are mutually exclusive, we say that these two events cannot happen at the same time. And in probability, when two events are mutually exclusive, we use the words like or, either, and neither. Okay, or, either, and what? And neither. And their probability are added together. Their probability are added together. That is to say, if we have x, y, and z to be mutually exclusive events, then their probability would then be probability of x plus probability of y plus probability of z. Okay, that's what it means. Okay, so let us then take some examples. Number one, a bag contains 4 red, 3 white, and 5 green balls. If a ball is picked at random, what is the probability that it is A, green or red, B, green or white, C, not green, A, red or green, B, green or white, C, not green? Okay, let us start. Solution. For the first one, which is probability of red or green, it will then be probability of red plus probability of what? Green. Okay, and the total number of balls, which is our x, okay, let's call it nx, is equal to 4 plus 3 plus 5, which is equal to what? 12. That's our nx. So the probability of red is equal to what? 4 over 12 plus the probability of green, which is 5 over 12. Is that correct? And therefore we'll have the LCM is 12. We'll have 4 plus 5, which is 9 over 12. Can it be divisible? Yeah, 3 can go here to give us 3. 3 can go here to give us what? 4. So we have our answer to be what? 3 over 4. 3 over 4. Okay, that's all for the A part of this question. Then the B, green or white. Let's go over to the next page. Green or white. So we then have a probability of green plus the probability of what? White. And our green is 5, our white is 3, and our sample space is 12. So we have 3 and 5. Okay, then we have 5 over 12 plus 3 over 12, which is equal to 5 plus 3 is 8. 8 over 12. 4 can go here to give us 2. 4 here will give us what? 3. So we have our answer to be what? 2 over 3. Then the C part of the question, this is our B. C part of the question said what? Not green. Not green. If it is not green, then it is red or what? White. So it means the probability of what? Red and what? Red or what? Or white. Red or white. Okay, so we now find the probability of what? Red or white. That is the probability of red plus the probability of white, and that will give us our red to be 3/12. Since okay, red is 4, that will give us our red is 4, and then our white is 3. So we have 4/12 plus 3/12, and that will give us what? 7/12. Okay, if you don't want to do it this way too, you can use 1 minus the probability of green, and the probability of green is 5/12. So have 1 minus 5/12. And what do we have? Our LCM is 12. Remember, this is 1 into 12 will give us 12. 12 times 1 is 12, minus 12 into itself is 1 times 5 will give us what? 5. So 12 minus 5 will give us what? 7/12, which is still the same answer. Then example number 2, a number is chosen at random from the integers 5 to 25 inclusive. Find the probability that the number is a multiple of 3 or 4. Find the probability that the number is a multiple of 3 and what? 5. So the first thing we need to do is to find a sample space, which is the set of 5, 6, since they told us is 5 to 25, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then 25. Okay, how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we have our number of sample space to be what? 21. Okay, so and we are asked to find the probability that the number that is chosen at random is what? The multiple of 3 or what? Multiple of what? 5. So we start by finding the multiples of 3. Multiples of 3. We have the multiples of 3 to be 6. We have 9. Multiples of 3 are those numbers that 3 can divide without a remainder. We have 9. We have 12. We have 15. We have 18. We have 21. We have 24, which is how many? 1, 2, 3, 4, 5, 6, 7. They are 7 in number. So the probability of picking the multiple of 3 is 7 over what? 21. Okay, then let's go over to multiples of 5. Multiples of 5. Those numbers that 5 can divide without a remainder. We have 5, 10, 15, 20, and 25. So 5, 10, 15, 20, and 25. How many are there? 1, 2, 3, 4, 5, which is 5. And then the probability of picking the multiple of 5 is what? 5/21. And I told us that the probability of the number that is picked is the multiple of 3 or 5, means the probability of 3 plus the probability of what? 5. So we have probability of multiples of 3 plus the probability of multiples of 5, and that will give us 7/21 plus 5/21, and that will give us our LCM is 21. Then we have 7 plus 5. 7 plus 5 will give us what? So we have 12/21, but we won't stop here. Now I want you to observe something, that 15 appeared as a multiple of 5 and also appeared as a multiple of 3. So therefore we cannot leave the both of them. 15 should be counted once. Every number should be counted once. So because of that, we then have 12 over 21 minus 1 over 21. This one now is for that second 15, so we subtract the second 15 from this, and therefore we'll have our LCM to be 12 minus, we have 12 minus 1, which will then give us 11 over 21, and that's our answer. Okay, so I hope you really enjoyed today's class. Thank you for being part of today's class. We'll stop here today, but before we go, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with addition law of probability. In our next class we'll go over to multiplication law of probability. So do well to use the lesson note on the platform for better information on what we've just done, and feel free to leave your questions or comment on the comment section. Till we meet again in our next class, stay safe and bye.